All right, here we go. We're going to explore the world of graphing quadratics. Hopefully you remember this from your Algebra 1 class, but let's go over it right now. What I'd like for us to focus on first is what happens when you have a table and how you know you have a quadratic, because that's something you're going to be tested on with MCAs. Now, when you see a table of values, one thing you can do is you can do, if you remember, what we call the loop-d's. And so what you're saying is, how do I go from 1 to the next? So how do I go from 5 to 9? I add 4. And to go from 9 to 3, I add 4. And from 13 to 17, I add 4. And from 17 to 21, I add 4. And then on the left side, all of these are plus 1s. And so what this is actually a linear function, and I can tell that because I'm adding 4 and I'm adding 1, and it's all the same number over and over again. In fact, that's going to be my slope, 4 over 1. Now if I go over to the other one, this one I would add 1, and then I would add 3, and then I would add 5, and then I would add 7. Now yes, there's a pattern going on, 1, 3, 5, 7, the next one's going to be 9, but it's not the exact same number over and over again. So then what I do is I do a second set of loop-d's, and I add 2, and then I add 2, and then I add 2. And this is how I know that this is going to be a quadratic, is because I did a second set of loop-d's to get my same number over and over again. You know, one kind of cool thing about that is when you have a linear, it's y equals mx plus b. And if you look, the x has an exponent of 1, and I only have one set of loop-d's. A quadratic has an x squared, right? It's an x squared problem, and I had 2 sets of loop-d's, so the exponent is 2. That's kind of a cool thing, actually. Now if we actually go and try and graph this 0, 0, 1, 1, 2, 4, 3, 9, if I go and graph that, I've got 0, 0. Let me make this a little bit bigger so I can be better at this. Alright, so we've got 0, 0, then I've got 1, 1, then I've got 2, 4, and then 3, 9, 5, 6, 7, 8, 9, and then 4, 16, 10, 11, 12, 13, 14, 15, 16. And so what you'll see is it's not a line, it's kind of curved. And as we go up here, it's going up steeper and steeper. And so that kind of also shows that it's not linear. Alright, that's the end of that page. Alright, so we have a parabola. This is the name that we give a quadratic graph, the graph of a quadratic. We call it a parabola. And if you remember, it's a U. It's either going to open up like this, or it's going to open down like this. Now, no matter which way it opens, it's always going to have a vertex. The vertex is that highest or the lowest point. It's called a vertex. So that right there is your vertex. We're going to spend a lot of time finding the vertex. Also, your vertex is always going to be on something we call the axis of symmetry. This is an imaginary line, so it's not a line that you actually see on a parabola. This imaginary line where if you folded on that line, if you folded the parabola in half, it would match up identically, which we're going to use to help us graph. Also, you'll notice that the vertex is on the axis of symmetry. Remember, a vertical line, such as these axis of symmetries, is going to be x equals a number. And so when we do this, when we graph this, we're always going to start out by finding that vertical line, and we're going to come up with an equation called x equals. And in order to find that, if you remember, we use negative b over 2a. Now, when I'm talking about b and a here, what we're talking about is we're taking the equation y equals ax squared plus bx plus c, and I'm taking that, and A, B, and C are my coefficients to those variables, and I plug them into this formula to figure out my axis of symmetry. And we'll practice that a couple times to help us out here. So let's practice a little bit now. So here I have some graph paper. Let's make up a parabola. Let's say y equals, let's do something somewhat simple, x squared plus 4x minus 3. So that's going to be my parabola. The first thing we do when we graph a parabola is we find the axis of symmetry. The very first thing. And so to find the axis of symmetry, we use x equals negative b over 2a. So let's think about this here. B is going to be our number in front of x. And so here the b is just the 4. A is the number in front of x squared. Now notice there's no number there at all. That means that a is going to be 1. So I'll go and I'll plug them in. I have negative, b here is 4. Be careful that if there's a negative there, you also include that in the parentheses. And a is 1. So we get negative 4 over 2 times 1 is 2. We get negative 2 as our axis of symmetry. So then I need to graph this. What I'll do is I'll start by graphing an xy axis. Let's see here. Let's open up. Let's go about there for my x-axis. Change color here for my parabola. So my axis of symmetry is at negative 2. So I'm going to put a dotted line, this vertical dotted line here at negative 2, just so that I have a reference for my flipping. All right, now the next thing that we do is we find our vertex. We want to find that point. So to do that, I plug in negative 2 to x. So we've got negative 2 squared plus 4 times negative 2 minus 3. Now the reason I'm plugging in negative 2 is because I know that my vertex is going to be somewhere on the axis of symmetry. And anywhere I am on the axis of symmetry, my x value is negative 2. So what I'm doing is I'm plugging in my x value of negative 2 into my original function, which is what we're graphing anyway. So now my math gives me 4 minus 8 minus 3. That gives me negative 7. Oh, phooey. Okay. So my vertex then is at negative 7 on the axis of symmetry. So 1, 2, 3, 4, 5, 6. Not quite enough room, but we'll make it work. So there's negative 7. There's my vertex. Now another thing that I like to suggest is making a table. And in that table, you can just keep track of the points you've gotten. So far, we plugged in negative 2, and we got negative 7. So that's my vertex. You can even put a V out there just to say, hey, this is where I'm centered at. And then we can just keep more track of what's going on. See, I need to plug in another point. And so the question is, what point do we plug in? You can plug in whatever you want. A good number to always plug in is 0. Okay, 0 is a very easy number to plug in. So I plug that in, and I get 0 squared plus 4 times 0 minus 3. All of these cancel out, so I just get minus 3. It'll be a really easy thing to figure out. Now, notice I have that point right there, and it's 1, 2 away from the axis of symmetry. So to get it the reflection, I go 1, 2 away on the other side, and I'm going to graph that point. And there we go. Now I want to graph, you always want to graph 5 points. It's one of your goals when you're graphing a parabola. So I need to graph one more point and then reflect it. Now I have all kinds of options. See, I could pick a point. There's going to be something in between here for x equals negative 1. So I could plug in negative 1. I could also go out here and plug in a positive 1. I could plug in a negative 3. That's up to us. We just have to pick one to plug in. By the way, I did mess up something here. This point right here I can record on my table. So that is x equals negative 4, and y is still a negative 3. Alright, I'm going to plug in a negative 1 just because I know it's going to fit on my graph. And plugging in a negative 1 to do my math, I get negative 1 squared plus 4 times negative 1 minus 3. So we get 1 minus 4 minus 3 gives me negative 6. So now I can graph that point. That'll be right here. And then I'm 1 away, so I'll go 1 away on the other side and reflect it. And that gives me negative 3, negative 6. And so my table has all 5 points. My parabola has all 5 points. And now I need to actually graph my parabola. And there she be. There is a parabola. So let's just remember what we did here to graph a parabola. Here are the steps. I suggest you take notes on this. Step 1, I'm going to find my axis of symmetry. Okay, you're going to find that by using x equals negative b over 2a. Step 2, you're going to find your vertex. You're going to use your axis of symmetry to do that. Step 3, you need to find 2 more points and reflect. Usually using x equals 0. If it hasn't already been used on your axis of symmetry or your vertex, usually using x equals 0 is a good one to start with. And there you have the 3 steps to graphing a parabola. Alright, let's go to the next page. Alright, so just once again, we're looking at this. The axis of symmetry is negative b over 2a. Apparently my typing is going to be off now that I translated it. And the vertex is also at negative b over 2a. So let's go ahead and graph another parabola. Here we have y equals 2x squared minus 8x plus 6. Alright, let's make this a little bit bigger here. So I start by finding my axis of symmetry, x equals negative b over 2a. Now on this one, my b is negative 8. And so I'm going to plug in a negative 8 there, but I also still have that negative from the formula right there. So I'm going to have 2 negatives, which will cancel be a positive here in a second, over 2 times 2 for a. So we have a positive 8 over 4. That gives me 2 as my my axis of symmetry. So once again, I need to put in my xy axis. Let's see here. Let's go there for the y-axis, and we'll go there for the x-axis. Now we found that my axis of symmetry is at 2, so I can put that in there. A little vertical line here. Alright, now let's go back to blue and keep on graphing. Now I need to find my vertex. To do that, remember I have this table that I'm setting up, and now I know I'm going to have a vertex at 2. So I'm going to plug that in for x. So I have 2 times 2 squared minus 8 times 2 plus 6. This will be 2 times 4 minus 16 plus 6. We have 8 minus 16 plus 6 equals negative 2. So I can graph in that vertex. So that would be on the axis of symmetry at negative 2. And then we can go and plug in 0 now. So let's see here, I'll plug in 0. And if I do that, I get 2 times 0 squared minus 8 times 0 plus 6. These all cancel out, so I just get 6. And so going back to my graph, I plugged in 0 and I got 6. 1, 2, 3, 4, 5, 6. And then I can reflect, which means now x is 4 and y is 6. So I need to put that on my table. So x is 4, y is 6. And why don't we plug in 1 just to fill in that space there. So if I plug in 1, 2 times 1 squared minus 8 times 1 plus 6, we get 2 times 1 minus 8 plus 6. 2 minus 8 plus 6 gives me 0. So when I plugged in 1, I got 0. That means if I reflect it, I also have 0. To fill in my table, I got 0, and if I reflected it, x is 3, y is 0. And then we can finish graphing. You'll notice this is kind of a skinny parabola. We're going to talk about this tomorrow, about what makes it skinnier than the other ones, and other things that we'll notice. Hopefully you remember a little bit from your Algebra 1 experience. But there is that graph, and let's do another graph here, I think. Yep, that's it for the graphs. This one's going to be kind of an interesting one here because we have a negative x squared. Again, we'll talk more about this tomorrow. I'm going to try and fit this all on one page so I don't have to keep bouncing back and forth. Alright, let's see here. This is going to be interesting. Let's go like this. This will be my y-axis. My x-axis we'll put maybe right there. Alright, axis of symmetry, let's head for it. So we've got x equals negative b over 2a. We've got negative 2 over 2 times, this time a is negative 1. We get 2 over negative 2, we get negative 1. So my axis of symmetry is x equals negative 1. Jump back to the blue for the actual graph. Now I got to plug in negative 1. Now you got to be careful here, you guys, with this negative out in front. It can cause us a lot of problems. So let's remember PEMDAS. PEMDAS says I have to do my exponent before I do my multiplying. So we cannot cancel our negatives yet. We have to do our exponent first. So I still have a negative. Negative 1 squared is a positive 1. And then minus 2 plus 12. So let's see here. That gives me 9. So on my table, I have negative 1 as my vertex, gives me a positive 9. So if I count this out, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is my vertex. Alright, then I want to plug in 0. That'll, since I can, it'll be easy. Also, I hope now we're at this point where we can see that if I plug in 0, these will all cancel out and I'll just get a 12. And then if I go and graph that, x is 0, y is 12, 9, 10, 11, 12. And then I reflect, that means when x is negative 2, y is 12. And then let's plug in, let's say 1 to see where we go. So we've got negative 1 squared plus 2 times 1 plus 12. Now remember, again, that negative is not being squared. So we get 13 here for our, is that right? This seems a little bit odd. Okay, interesting. I actually did a mistake you guys do a lot. And so here's what I'm going to point out. I got 13, and you'll notice if I graph those, this parabola would be coming down right here, and then it would have to go flare out. This is not okay to have a picture like this. And so what you should be doing is you should be then questioning your axis of symmetry and asking, did you actually get the right axis of symmetry? What you'll notice, I actually found it, is I have a negative here and a negative here, which means I should have a negative here and a negative here, which means that should be a positive 1. So let's see here. If I go back, if I can erase, they won't let me erase. This is so ridiculous. Alright, so let's see if I can fix this. I can't even fix my graph. We're going to have to change colors so I can tell the difference here. If that's okay with you guys, you just bear with me here. So this is going to be a positive 1, which means my axis of symmetry here is at a positive 1. So life is not over here because, here's the cool part, I've already actually got a lot of points. So I've got a positive 1 for my vertex, which means that I did the math here right. So this is actually my vertex. 1 here is my vertex, and I just moved things weirdly, didn't I? Oh, could this lesson get any worse? Oh my gosh. Alright, let's try it here. So let's plug that back in there again. Alright, so here's my vertex. This is still a point, and I can reflect it over here. And then this one's still a point, and I can reflect it 1, 2 away, 1, 2 away over here. And so I still have my parabola. Notice this time the parabola is open down. Okay, and there she be in red. As ugly as that is, you all get it. And it does happen. You make mistakes, and you just have to go back, and usually it's where your axis of symmetry is that you made that mistake. And that is how you graph a parabola.